for her statement on Open RAN. Commissioner Varsnasi.
Thank you, and good afternoon. It is a treat to join you to kick off the final panel of the day, a technical deep dive into open radio access networks. Now, I might be the last one of my colleagues to address you today, but the record will reflect that I was actually the first commissioner at the agency to speak extensively about the power of Open RAN, and that was more than a year ago. And it's for good reason. Open RAN has extraordinary potential for our economy and our national security. That combination is something to seize, especially right now in the early days of 5G deployment. You know, our 5G future is about connecting everything. It's about radically higher speeds and lower latencies, opening up possibilities for wireless that we can't even fully imagine today. If we do this right, it could render our smartphones the least interesting thing about the future of wireless technology. Think of it as instead as an input in everything we do, bringing new efficiency and effectiveness to every sector of our economy. Now, doing this right also means putting security first, and it means recognizing that this new connectivity brings with it a whole lot of vulnerabilities. And to date, the FCC has focused its efforts in this area on limiting the deployment of insecure wireless technology by restricting the use of network equipment from Chinese companies. We have encouraged our allies around the globe to do the same. But we shouldn't be lulled into a false sense of security by flashy and well-promoted decisions about hardware and administration headlines about Huawei and ZTE. That's because the 5G cybersecurity challenge is much bigger than simply dealing with a few Chinese companies. Restrictions on Huawei and ZTE are a minor fix for a much larger problem. While we can ban a few specific products, services, or companies, no country can isolate itself completely when we are connected worldwide. Plus, our national ambitions are far too great to be defined only in relation to a single country. We must focus now on our competitiveness, on strengthening our alliances around the world, and on reasserting our values by building a new market for 5G equipment. That, I believe, is how we will restore American leadership and secure 5G. This is ultimately what Open RAN and this whole conversation is all about. It's about making the market for 5G equipment both more competitive and more secure. So at Mobile World Congress last year, I explained that if we can unlock the RAN and diversify the equipment in this part of our networks, we can increase security and push the market for equipment to where the United States is strongest, in software and semiconductors. That means we can increase vendor diversity and in the process increase competition and resiliency. Plus, we'll all benefit from software-centric innovation in radio access networks and faster upgrade cycles than with traditional hardware. Now, I've since testified about this idea before 4 different congressional committees, 4. So I can say with authority, momentum is building. But we do have more work to do because not everyone is convinced. Earlier this year, the Attorney General of the United States called Open RAN just pie in the sky. But one company has already made it into the history books as the first to launch an Open RAN network in Japan. And Open RAN hardware and software is now projected to reach 10% of the total market in the next few years. And so I believe that if we want to lead in the development of Open RAN, then we need to take action now to help build this momentum and this movement from the ground up. And gathering today and learning from one another is a great start. But there's more that we need to do. First, we need investment in research and development, both from the government and the private sector. There's a bipartisan bill in Congress right now called the USA Communications Act that would have the FCC provide $750 million to accelerate the development of Open RAN in the United States. This is a good idea. Second, we need to launch an Open RAN test bed that brings together operators, vendors, vertical interests, and government agencies. That's something we can help do right here at the FCC. Even better, we could build this onto our ongoing work with the National Science Foundation to authorize citywide test beds for 5G in New York and Salt Lake City. Third, we need to build scale economies for Open RAN technologies. This happens when we coordinate with other agencies here at home and increase participation in international standard-setting organizations that are doing work abroad. And as we move forward with plans to remove insecure equipment, that is already in our networks, we should consider incentives for replacing that equipment with Open RAN architectures. We also need to build incentives for producing the next generation chips that Open RAN technologies will require. And that includes research into the use of gallium nitride chips, because early research shows it could be more efficient than traditional silicon chips for 5G technologies. So that's a lot of work. But look at the expertise we have gathered virtually today. I want to thank you for being here. I want to thank you for listening. And most importantly, I want to thank you for being part of creating a more secure and competitive 5G future.
Thank you very much, Professor Rosenwasser, for kicking off this final panel with those.
I appreciate that you just upgraded me to professor. Well, it's good, Commissioner.
Commissioner.
Thank you. I appreciate your time.
Professor. Thank you very much. Panelists, could you please turn your cameras and microphones on? Okay, so this has been a long day, and I hope most of you on the panel, as well as in the audience, had a chance to listen in to the morning and early afternoon session. There were a lot of very interesting, and I would say at sometimes maybe even provocative questions raised in terms of what the promise of Open RAN can be and should be. What I'd like to do with this panel, with the experts that we have on today, is take a deep dive into a few of those technical issues that were raised and try to really tease apart what is available today, what is possible today, what the technical challenges are for Open RAN to truly become a next generation architecture. I've always thought that maybe Open RAN is the way to get rid of all G. I mean, we are stuck in this generational mode of thinking of one G following another. And now when we are in this mode where we can continuously evolve with an open radio access network architecture, should that be the path we are taking? So that's just one among all of the other technical issues that we want to raise and discuss in this panel. So the way I'd like to do this is a little bit different from the previous panels. We have 10 extremely accomplished experts in their field. I won't go through their bios. Their bios are all listed on the FCC website, but what I will do is just go down the list in alphabetical order, give each panelist about a couple of minutes chance to just express where they're coming from into the Open RAN discussion, and then we'll take it from there into a question and answer and discussion phase. So without much ado, Mihai Banu is from Blue Danube. Mihai, please go ahead and introduce yourself and just get started. You're muted.
Okay, thank you, Monisha. Good afternoon, and thank you for attending this panel. Today, I want to focus on the challenges implementing ORAN for massive MIMO systems in the sub-6 GHz bands. This will include the 7.2 ORAN split. Massive MIMO is used for 3D beamforming, which is the key feature for the most advanced 5G radios. The widespread use of 3D beams is a prerequisite for delivering the highest capacity in cellular networks. This is particularly important for mid-bands like 1.5 to 4 gigahertz and so, because these are the most valuable bands with a good propagation and reasonable bandwidth all at once. As we know, low bands suffer from insufficient bandwidth and millimeter wave bands suffer from poor propagation. Another important thing that we need to remember is that a large portion of the mid-band spectrum is FDD. Conventional massive MIMO technology is fundamentally more difficult for FDD than from TDD due to the lack of channel reciprocity. So let us talk a little bit about the ORAN challenges. Conventional massive MIMO requires a large number of digitization stages, such as 32 or 64, resulting in an equally large number of very high-speed digital streams, which need to be processed in real time with powerful signal processor and sophisticated software. So on one hand, massive MIMO makes the RAN system significantly more complex and more expensive than regular MIMO. But on the other hand, we want to split this complicated system into portions any vendor can implement with 100% guarantee to connect flawlessly with the other portions provided by other vendors. No wonder there are so many technical disputes on this topic with obvious vendor biases and many rumors in the industry that O-RAN will take much longer to become a real open standard than we hope. At Blue Danube, we believe we have a solution to this problem. In our opinion, the issue is not O-RAN per se, which is rather straightforward to implement in MIMO with a reasonable number of digital streams, but rather the issue is conventional massive MIMO, which is unnecessarily complicated with a very large number of digital streams, a brute force approach. Our answer to is the concept of coherent massive MIMO, as illustrated in the slide I prepared for this panel. Can you please show that first slide, the one slide that I have? I don't know. I cannot see it, but is it shared?
It's coming. I think Evan is going to share it.
All right. First, let us focus on the hardware coherency matter illustrated at the bottom of this slide. For any active array, the only way to make a predictable 3D beam natively without any DSP is if with all active array elements are almost identical electrically. In this case, the array is coherent, and the average phase error between elements is 5 degrees or less after all the hardware calibrations, and this has to be for all operating conditions. An example of hardware coherency is provided by any military radar phased array, for example. The conventional massive MIMO on the right does not use hardware coherency and instead divides the antenna aperture into many small subarrays connected to many individual radios to individual digitizers. Then it relies on channel sounding and mapping. Hardware and processing are obvious. The coherent massive MIMO system on the left digitizes the entire aperture of the array, but only as many times as the maximum number of layers we expect. Each digitized stream represents a different independent analog 3D beam created simultaneously by the coherent aperture. This is where the hardware coherency plays the key role. I also stress that digital 3D beamforming between the digitized streams can be done as in the conventional massive MIMO system, but with far less reduced complexity. Also, coherent massive MIMO works naturally in FDD as well in TDD. Blue Danube has a very low cost and efficient technology to maintain hardware coherency under all operating conditions and to create any set of agile 3D beams by hardware in addition to digital beamforming. No DSP cycles for hardware calibration are necessary. So the bottom line is that since our coherent massive MIMO uses far fewer digital streams than conventional massive MIMO, the O-RAN split for this system is fundamentally simpler, similar to conventional MIMO, and therefore can be brought to practice reality right now. Thank you very much.
Thank you, Mihai, for jumping right into the technical details of what makes massive MIMO O-RAN system work. That's excellent. Charles,
it's supposed to be a deep dive, right?
Absolutely, and thank you very much for kicking it off so brilliantly. Charles, I'd like to go to you next for your opening statement.
Sure, thank you. So my name is Charles Clancy. I'm an executive with the MITRE Corporation. And at MITRE, we have, I think, a unique vantage point across the entire federal government of a lot of exciting things that are happening in 5G with adoption in different agencies, interest in standards and policy and rulemaking in different agencies. And I think some of the key things that I think that are exciting, particularly from a technical perspective about this, is really the use of artificial intelligence and machine learning in 5G. If you look at the role that machine learning can play in how we optimize resources within our RF environment, it opens up a whole new set of capabilities to deal with a wide range of deployment scenarios. So in a typical, I don't know, US urban environment, you might be worried about kind of congestion in the RF environment, lots of cell towers that need to all optimize around each other, potentially some limited interference, but not significant. And in that scenario, the radio intelligent controller that's part of ORAN, I think, provides a whole interesting set of opportunities for doing all that optimization. But if you think about more hostile environments, particularly as the Department of Defense considers using ORAN in some of its systems, you get a whole additional set of capabilities when you start working with more of a contested RF environment, not just congested. So the ability to manage around sources of interference or jamming becomes a really exciting component that I think the machine learning aspects of the ORAN, radio intelligent controller, can provide. I think one area that's a little bit understudied so far is security, and so that's my personal area of interest and expertise. We haven't really thought through the threat models for ORAN yet. For example, do we need to be encrypting the front haul link between the CU and DU? Is that something that's even necessary? What are the risks of intercepting these signals over a fiber optic cable versus over the air? A lot of open questions, I think, still around really what security is needed. But suffice it to say, the more you're going virtual, the more things are being provided by third-party apps. We need to make sure we think through that end-to-end in terms of security. And third, I'd say we really just need to ground what we're doing in use cases. ORAN in the abstract can be very complex. It can mean a lot of different things. But if you start talking about specific use cases, whether it's radio resource orchestration for drones, or it's dealing with contested RF environments for public safety applications, I think we can then really start to firm up what we need out of ORAN now versus what we could get out of ORAN long term. Thank you.
Thanks, Charles. And those are topics that we are going to delve into in greater detail as we go along. Next up, Cheryl Davis, could you please just tell us a little bit about yourself and where you're coming into it?
Sure. Thank you so much. And I'm very honored for the opportunity to be here with you all today. So I'm part of Oracle here, and we are a leader in telecommunication solutions with a global footprint, supporting communication service providers as well as our enterprise customers. So why are we here talking Open RAN? Well, as we're offering our 5G technology that's built on our cloud, and Open RAN is very important to us, and just a few points on why. We provide our 5G service in software so that our enterprise customers have 5G for their IoT needs. So we have to be able to ensure that that service works with whatever and whomever our customers select for connectivity. Therefore, we have to be able to operate with the vendors in the RAN space. And so moving to a RAN that's open, interoperable, and standards-based allows us to integrate with the rest of the system, ensuring that our customers can capitalize on this technology. And as parts of the RAN could also fit as cloud deployments, certainly we will be following these developments and opportunities. And so just our view on looking ahead, we view that a 5G solution that is open, interoperable, and standards-based will really unleash the next wave of American innovation, as we've heard today. Moving from this monolithic model to one in which a large ecosystems of vendors can work together to deliver 5G solutions is important for supporting multi-supplier networks, and that's a core principle in security. And so because our customers are deploying these open and standards-based 5G solutions, they have the opportunity to integrate future innovations, whether they be in 5G or beyond, in a timely and cost-effective manner. And we're very eager to be a part of this and to also bring some of the security and innovations that we've been able to develop in the cloud into the 5G system. So thank you again for having me here, and I look forward to our conversation.
Thank you, Cheryl. Ashutosh, you're up next.
Can you see me? Okay. Yeah, hi. Thank you very much, Dr. Ghosh, for inviting me. My name is Ashutosh Duda. I work for Johns Hopkins University Applied Physics Lab, which is a university affiliated research lab. We work with many government agencies, Department of Homeland Security, Department of Defense, US Army, Navy, to see how the evolving 5G technology can take care of many of the pain points they have, how they can use 5G technology to make their operation or ConOps more efficient, how they can take advantage of many of the 5G pillars that we have today to support variety of applications like massive content, massive, low latency application, IoT type application, and how they can make the network more reliable and flexible and adaptive. So all these things can happen because of many of the 5G characteristics we have today. I think it was mentioned in the earlier panel, things like software-defined networking, network function virtualization, mobile edge cloud, orchestration, network slicing, edge security, among others. As the previous panelist one mentioned, the previous panel, Mary, I think, many of these have been deployed in 5G core. Now what we're doing, we are trying to bring that to radio access network as part of the O-RAN open architecture and to provide the same amount of flexibility to support this kind of network dynamicity or make the network more adaptive. So as you can see, these characteristics have lots of benefits that we can take advantage of, right? But at the same time, in addition to the actual benefits, they also provide, I'm focusing a little bit on security, the embedded security function, the inherent security function they have. Think example of software-defined networking or network function virtualization, right? If you have that and you have the orchestration facility, how can you scale up, scale down the network and still provide the resiliency when there is a denial of service attack taking place, or there is a heavy performance overload? How can you take care of network slicing to provide isolate the mission critical application from non-mission critical application? So that is a security, inherent security as part of network slicing. Similarly, you can make use of closed loop automation, dynamic service chaining to detect the attacks and mitigate it within a reasonable period of time. So these are some inherent security benefits that we can take advantage of. And if we apply these to Cloud RAN and still provide this kind of automation, you can really make use of these enablers to support billions of IoT devices, support ultra low latency, massive content, and make the network flexible. So these are the opportunities like programmability, virtualization, embedding the DDoS detection monitoring functions. How can you correlate the data traffic and control traffic at the edge of the network so you can detect it early enough to mitigate the attacks? That's so important. And this can be done by virtualizing the RAN. So while I talked about the added benefits, there are also challenges that we need to think about, right? We should not be, I think the commissioner said before, it is not only supply chain security. We have to think about what are the additional security challenges we have to take care of while we deploy these enablers, right? If you think about virtualization, you have to think about side channel attacks due to virtualization. If you're employing or deploying slicing, there are potential risks between slice to slice attacks or impersonation of slices, slicing manager attacks. If you're putting the virtual network functions with firewall functions on the Cloud RAN, when there is a denial of service attack happening, you're scaling up, you're adding more virtual functions or firewalls. Can it start the resources from other DNFs, other third-party application? You have this automation, which is an interesting fit, a real benefit, right? But if you have the orchestration, you are depending on the APIs. So you need to think about orchestration security. You need to think about northbound, southbound API for the SDN controller. So these are the things you have to really think about. So there are opportunities by moving into O-RAN. There are security opportunities. There are security challenges that also we need to think about. And as Charles said, we really need an in-depth analysis of end-to-end component interfaces, open it up, come up with a threat taxonomy, come up with the security best practices, and then at the same time, build testbed in use cases, right? How can you support our government, different agencies use cases and take advantage of 5G enablers at the same time, make it secure. I think those are my takes, Manisha.
Thank you very much, Ashutosh. Yeah, and I don't remember who, but somebody made the statement of it's easier to find cockroaches with the light turned on. And I was just thinking that, yeah, but then they find new hiding places with the light turned on and you have to go after them. So yes, by opening up the network, we do make some things easier, but we are probably changing the threat models and we have to go after the new ways that the network can be compromised. Laurie, can we have you up next? Laurie is representing, I guess, the sole carrier on this panel. She's from Verizon. Go ahead, Laurie.
Oh, Manisha, thank you so much for the invite for today. Verizon is excited to participate, and we're extremely interested in advancing Open RAN and have already been working with existing and new vendors to help with that effort. The potential for small technology companies to have a presence in the RAN business and allowing them to scale at their pace is a great opportunity, and we fully intend on setting up challengers to be successful in this space. Tasks like taking cloud to the edge, decoupling the RAN, creating a flexible architecture, and bringing more vendors to the RAN ecosystem are tasks that are being advanced rapidly by Verizon. So we know that many of those tasks will be tackled in the O-RAN Alliance and participation in ORPC, and these will be critical to promoting the technology. And we helped bring 5G to fruition, and we're a player in O-RAN as well as an early adopter. So as one of my colleagues says, network architecture disaggregation through open interfaces, it's a journey. And we're kind of at the first step of that journey, which is the ability to mix and match baseband software with an open RU. And we're excited because there's future stops. And we hope that that'll include additional disaggregation and open interfaces beyond baseband and RU. There's strong evidence that O-RAN is driving a diverse US-based ecosystem. The challenge that we see at Verizon is scale and maturity. We have a mature network here at Verizon, and it's not a greenfield network. We support O-RAN entirely and know it is the future. We will be adopting this critical architecture and in a time frame that successfully allows the network to mature gracefully, but at the same time protecting our customers. And that is really the key for mature networks, like many of the tier 1 operators, is making sure that we get these needed technologies like O-RAN quickly and as painlessly as possible for our customers. So I wanted to thank you again for the invite and looking forward to the discussion today.
Thank you, Laurie. And I think that echoes what we heard in the previous panel about how the incumbent entrenched providers are more beholden to being backward compatible or supporting existing users, whereas the new entrants can be much more agile and jumpstart and move quickly over to newer technology. And that's a challenge that the industry has to be able to embrace and come to terms with. Thanks. Manu Gosen.
Hi, good afternoon, and thanks for the invitation here. Manu Gosen here, and to connect the dots, I'm here representing the opening comments that Commissioner Rosenworcel made for the Open RAN testbed mentioned in New York City and Salt Lake City, representing the PAWR Platforms for Advanced Wireless Research Public-Private Partnership testbed between the National Science Foundation and 35 members of industry. These platforms have been built since 2018, so we were at the forefront of building open, disaggregated end-to-end network architecture testbeds. These testbeds are available for testing today, and I would urge you and encourage you to sort of think of these environments a little bit differently than a lot of the community labs and system integration labs that you may come across. These testbeds have been built both vertically as well as horizontally. Vertically in the sense of having an end-to-end network architecture with all the different disparate elements from the radio access network, the CUDU, RU, back into the edge, into the core, but also horizontally, aka within each module, there is the ability to stack different pieces of the puzzle in new and varying ways. These testbeds are pre-commercial. They are at a TRL level of 3 to 6, which allows for early prototyping, proof of concepts, and trials as well. And Open RAN was sort of built from the start in keeping these principles in mind as these testbeds were built. Manisha, if you mind putting up the slide, that'd be helpful. Thank you. Thank you. So these are the current portfolio of this public-private partnership. You're going to hear from 2 of the 3 later on. And the fourth one, which we heard a lot of in today's conversation, was around rural broadband. And very encouraged to hear some of the comments made by the FCC commissioners around the thinking that's going around the RIP and replace program and trying to think about how do greenfield and brownfield deployments in a rural context come. So we have a platform, a test platform that's going to be selected, and it's going to begin its deployment and construction in 2021. So it'll be interesting to see how that journey maps the journey that's being advocated for within the FCC. Next slide, please. And in terms of sort of the open research problems, sort of we see this mostly, the biggest one is algorithmic frameworks. So the big one would be allowing innovation or allowing visibility for our community, which is the academic community, to look under the hood and to give us more exposure into the parameter space more fully, so new algorithms can be developed and can be deployed. In addition to that, we need to think about how these algorithms can be deployed on these different disaggregated CU, DU, and RU splits and allow for innovation in an open, a truly open ecosystem. A couple points that we'll probably discuss later come to mind around artificial intelligence and its role, especially around the radio intelligent controller. As the RAN gets disaggregated, there are now more touch points to gather data. And as more data comes in, that sort of strengthens the story that we heard earlier today around measurements and the role of AI. What we believe or what we are exploring in the context of power and in the general ecosystem are the ability to develop data sets for training, inference, the ability to compare paradigms of offline and online learning, as well as optimizing the three different latency bounds that have been built into the ORAN ecosystem, namely the real time, the near real time, and the non-real time. Open test beds, which is obviously where we're coming, we need open test beds for innovation, and this needs to be democratized to access not just the startup ecosystem and the incumbent vendors, but another major pillar, which is the academic community. So these platforms that we built and we operationalize, we still need to, we think about these as a bridge that connects Open RAN research before it goes into commercial or pre-commercial trials, especially when the early innovation concepts are being tested. On the X-Hall piece, again, now you have three different front hall, mid hall, back hall pieces. And on top of that, to connect all of them, you have this intelligence in the rig that ties it on with what are called X apps. To anybody familiar with the iPhone ecosystem, the apps are going to be developed in this Open RAN innovation ecosystem that allow for deep vertical integration of technologies and solutions in the form of applications, which are nothing more than a bunch of containers running on top of a Kubernetes stack that can be deployed and chosen by the operator to meet the objective that they may want. So these are sort of the four main research challenges, and hope to delve into that. Back to you, Manisha. Thank you.
Thank you, Manu. Yes, we will do a deep dive into a number of the issues you raised later on. Let's move on to Amit Jain. Amit Jain comes to us from Virana Networks, a brand new startup in the space of millimeter wave, and he'll tell us about how ORAN plays into their strategy.
Thanks, Manisha. So as you mentioned, Virana Networks is a startup. We are focused on radio access networks for millimeter wave spectrum, and I would say we are really counting on Open RAN for our success at this stage. So as all of you know, the FCC has licensed close to 5 gigahertz of millimeter wave spectrum to wireless service providers. And this is 7 times more licensed spectrum than what has been available for mobile services in the 600 to 2600 megahertz band. Millimeter wave spectrum is today supported by it's part of the global 5G standard. You have number of semiconductor vendors and handset vendors who claim that they have millimeter wave handsets and CPEs. Yet hardly any carrier in the US right now is planning to build a nationwide millimeter wave network. I think Verizon is further ahead than anybody else, but still they are doing a number of large cities, some deployments, but nobody so far is saying that we're going to offer millimeter wave service to like 70% or 80% of the US population. And the reason is simple. A millimeter wave network requires 15 to 20 times more cell sites than a network in the lower frequency bands. And the cost of building a millimeter wave cell site is not 15 to 20 times less than the cost of building a low band or mid band cell site. So this is a huge problem. And I think unless we solve it, millimeter wave spectrum will not get utilized widely. And I think that Open RAN can actually help in solving this problem. Now, speakers this morning, others talked about two aspects of Open RAN. First is virtualization, the ability to run RAN functions as software on off-the-shelf hardware. And the second topic that almost everybody brought up was how Open RAN brings open and interoperable interfaces to the network. Now, actually, I don't think that virtualization really helps millimeter wave, because if what you're going to do is, if you're going to run millimeter wave 5G on the same off-the-shelf hardware on which you're going to run mid-band or low-band 5G, it is not going to make millimeter wave 5G 15 to 20 times less expensive on a per cell site basis. It will basically end up costing about the same. So if we really want to drive down the cost of 5G deployment in millimeter wave, I do believe that we need innovation in hardware design. And I think in the US, we are pretty good at hardware innovation. So where Open RAN really helps the deployment of millimeter wave is through open interfaces. And I think it is these open interfaces, as well as all the methods and procedures for integration and interoperability, that can enable new vendors, new startups like Verana to enter the market. Because 5G, for all its strengths as a global standard, is still, it's very complex. It's an evolving standard. 3GPP comes out with a new release every 12 to 18 months. Carriers absolutely want to embrace the features that 3GPP brings. So you require not just initial network integration, but continuous interoperability and integration in the network. So with Open RAN, and now new entrants can focus on what they can do best. New entrants don't have to try to build the entire RAN from the grounds up and keep evolving it. And I think this is the method through which we can expand the vendor ecosystem. We can, as a small entrant, as a new innovative entrant, we can work with others in the market and partner and put together a solution that makes sense for service providers in the US. And that's, in a way, at a high level, that's what we are looking to do.
Thank you, Amit, for that. And yes, that's one of the topics that's always been on my mind, is when we talk about O-RAN in the context of today, it's usually in the mid-bands. Moving up to millimeter wave does open up, I think, a whole new world of challenges in terms of front haul, in terms of all of the other control aspects of beamforming that need to be fully explored. So let's move on to James Skimmery from Spirent. James is a well-known figure in 5G, and he's recently moved to a new company, and I'm sure he's carrying on his work on 5G in Spirent as well. James.
Thanks, Manisha. I appreciate the opportunity to be able to speak on this panel with all of you. First and foremost, I wanted to talk about two different topics. Both representing my former company and my current company, both research and test and measurement. I think one of the exciting aspects of Open RAN is this concept of open interfaces. And by having these open interfaces combined with open source software, you can see where this ecosystem from a research perspective can be created. I mean, one of the challenges that we see in terms of the research community is if you have to basically reinvent the wheel every time you develop a prototype, it gets very, very expensive. And being able to utilize open systems and open interfaces enables researchers that may have one particular aspect of the network that they'd like to optimize and experiment with. They don't have to be an expert on all the other pieces. And I also think that O-RAN in and of itself, because of this interoperable open interfaces, that more commercial companies will be able to participate in these test beds. In prior generations, with proprietary equipment, researchers had difficulty tapping into the equipment that was provided, and a lot of times it was difficult to use. So that combination of open interfaces, open source software, I think that could really create a more robust, advanced prototypes in the future, and that's what we need as we evolve the networks. One quick point about test and measurement. These open interfaces, they create opportunities for testing. Each of these interfaces must be tested. And I think one of the things that people have asked me this, well, if you have to test all the interfaces, isn't that going to increase the cost of the system? And in my experience, I think no. And in fact, as you build a CU, you build a DU, you build an ORU, then these systems can actually be tested independently without access to a CU or DU, an RU, or any combination thereof. So that also facilitates testing earlier on in the design process. You think about actually doing performance testing on an RU without the baseband being present. Well, you can do that. That's what ORAN facilitates in this context. So in closing, I just think that ORAN is going to change a lot of things. It's going to change, hopefully, the way that we research, the way that we test, and hopefully the way that we deploy next generation networks.
Thank you, James. Yvonne?
Yeah, thank you very much, Manisha, for the invitation for the panel. So Manu already talked about power, so I'll try to stay away from it at least a little bit. So I'm a program director of one of the two testbeds that Manu was mentioning. Are actually 3 power testbeds, namely the Cosmos testbed in New York City in West Harlem. But rather than talking about the millimeter wave and optical stuff that we have in the testbed, I wanted to touch on related topic of how the industry views these testbed platforms, and to sort of touch on the experience we had with both ONAP automation, that we've been hosting these POCs, ONAP POCs, for the last couple of years, and now moving towards the so-called establishment of OTECs, and both OTECs, the OTEC East, which is actually part of Cosmos deployment, as well as OTEC West, which Kobus will talk later on about, are actually, OTEC stands for ORAN Alliance Open Tests and Integration Center, are being established right now. And so a couple of experiences there. Really, the fact that we are facing something that we haven't faced before, which is an enormous increase in complexity of these systems. So testing the complexity becomes a crucial aspect. And when I say that, there are a couple of issues, right? So quite often we have stated performance promise that these systems are supposedly delivering. And then when you measure it in the context of integration, you suddenly start seeing completely different numbers. And so this is something that we've seen in these POCs, and quite often they require hands-on and on-site presence, where people are now suddenly tweaking things, trying to tune them up. So in other words, individual testing is not enough. You sort of need to put this into context of deployment of big system, and not just interoperability between individual components, but sort of putting it all together end to end. And quite often there are a lot of surprises when you do it for the first time. Another thing is that we are sort of seeing this difference in sort of industries, to call it that. We have on one hand traditional vendors who are building reliable telco VERTI equipment that is being deployed. And on the other hand, you have the agile software development culture that's suddenly jumping in. And that creates a huge problem, right? So we need to sort of merge the two societies somehow, or two groups. And that's an interesting thing that we should think about. And then finally, one thing that's actually a couple of people already touched on is that we need, in order to make this really widely available for the community to develop new and better things, in other words, move beyond what we are traditionally doing with the telco equipment, which is to sort of create this new value on top of it. We need to have these well-defined and absolutely open APIs on top of everything, so that we can, and of course, test facilities to go with it, which are fully open and available to community at large, not just the main participant in this discussion. And of course, hope is that, as was the case with the opening of the application ecosystem for mobile devices, we will suddenly see things that we never thought about, right, being developed and deployed. So this is where I would stop and hopefully discuss more technical details later.
Thanks, Ivan. I think you bring up an interesting point about, two different communities, the software community and the traditional networking engineering community. We heard about workforce development from a different angle in one of the previous panels, but there is also the workforce development of a new breed of engineers who have to meld together the software programming piece with the network knowledge, the wireless network and the core network knowledge piece, which is something that academia especially needs to, I think, gear up for if ORAN is here to stay. Finally, we have Cobus. Cobus is also the PI of one of the power platforms, and I will let him talk a little bit about the power platform in Utah. Cobus, I guess you want your slides up at this point, right?
Yes, please. That'd be great.
Thank you.
So my name is Cobus Vandermeer. I'm a professor in the School of Computing at the University of Utah. In the context of this panel, I am also the director and the principal investigator for one of these NSF and industry-funded platforms that has already been mentioned. So just to sort of set the context a little bit and sort of where we're coming from, there's a sense in which the softwareization and the opening up of the radio access network is just the logical next step in the open software-defined networking evolution that has been going through networking more broadly. I think an important point, though, is when we talk about the radio access network, it is way more complex than any of the other networks where these open technologies or open approaches have been applied. And so sort of as a position statement, I guess, and I'm echoing what several others have already said. I think there's in the case of Open RAN, there's a tremendous need for practical experimental exploration, validation in a realistic environment, and being able to explore use cases, explore the complexity of the interfaces, explore the security thereof, explore the new attack vectors that are enabled, as it were, in an Open RAN environment. And so that's kind of the context of the Power platform that we are developing is really meant to enable this type of research. And so the picture here, and I'm not going to walk through this in great detail, but this is sort of a comic version, if you will, of the platform we are developing here in Salt Lake City. We have a variety of endpoints. We have a variety of radio nodes in the RAN, both at street level and rooftops. We have edge compute. We have a private fiber front haul and back haul. We have a metro cloud environment. We have a controlled RF environment. So in some sense, we have a ready-made wireless lab that is being built in the real world to enable this kind of research. So next slide, please. A fairly unique thing about our platform, and again, this ties in with sort of the general trend in industry as a whole, is that this is software defined end-to-end, right? So all of those little building blocks in there, you can think of as running on general purpose hardware. And so the functionality is defined by the software that you put on there. And so that gives huge amount of flexibility in terms of experimentation and research. And so that's what's kind of shown on the top left there. And in the top right, we also have what we call a bring your own device model, where you can kind of in this whole architecture come and plug in your own devices at the various layers if the platform we provide is not what you want. So that's in a nutshell the Powder platform. And so the figure at the bottom is just to make it a little bit more real in the context of Open RAN and specifically some of the things that we are doing. So if you take this general purpose hardware, right? So a cloud compute platform, software-defined radio, and you combine that with software, and oftentimes the software can be open source software, then you can get this end-to-end open source Open RAN environment. And this is something that we're specifically working on by taking the open source components that's coming out of the ORAN Alliance, and we're kind of combining that with other open source stacks out there in the form of Open Air Interface and SRS LTE to get us to this end-to-end open source environment. And then just to echo some of the things that one of the earlier speakers said, a key thing that we try to enable in our platform is that you don't have to be an expert to use this. And so for anyone who've tried to stand up any of these software stacks, you'll know it's super complex to do that. And so we follow this kind of Lego building blocks approach throughout our architecture. And so we try to provide building blocks where you can sort of, by a click of a few mouse buttons, instantiate an ORAN environment or an SRS LTE environment and have that as a building block on which you can then build. So we're doing some of our own research on this in the ORAN environment, but I want to emphasize that Powder is a platform that is open to the community at large, both academic and industry, for research and development. Thank you.
Thank you, Cobus. I mean, as someone who came to the FCC from NSF, I cannot reiterate the importance of having these openly available test beds, because a lot of what we heard about innovation and about new companies and new entrants, all of this is going to happen from people who are maybe in school today. And for them to get their hands on these test beds where they can actually play around with these kind of networks is what is going to seed future innovations. So thank you all for your opening remarks. What I'd like to do now is go through a list of questions, and I will, ask you to engage in some discussions about it. So the first one is about use cases. We heard that term very often, not only from you guys, but also in the previous panels. So what are some of the use cases that you think are uniquely suited to Open RAN? Are there certain splits and configurations, for example, that you would prefer to use in urban areas and hotspots? Are there performance trade-offs which make sense in some situations and not others? We heard the number that only 10% of networks will have ORAN, will be ORAN in 2025. Now, should that number be higher, or should that be more targeted to a specific applications that would benefit the most? So I'd like to start off with asking Charles Clancy about your thoughts on this topic.
Sure. So I think there's two types of classes of use cases to consider. One is potentially the deployment scenario use cases, where your motivations are really more economically driven, right? How much it's going to cost to deploy a particular type of technology in a particular metro area, for example, and you may get cost or economic sort of efficiencies out of ORAN as enabling technology. I think the other way to look at it is from an application perspective, right? What are the applications that are going to be the killer app for 5G that could be uniquely enabled by ORAN and perhaps not by a more monolithic RAN architecture? So I'll get back to really, I think the radio intelligent controller, the RIC within 5G is within ORAN is one of these key things that can enable applications better and faster perhaps than you get in a monolithic ORAN RAN architecture. And so in particular, a use case I'm uniquely excited about is UAS. So as you think about commercial drone operations, you're doing optimization of everything. You've got to do route optimization of the drone in order to get it where it needs to go, achieve air traffic control functions, air safety functions, flight operations functions. But at the same time, a drone has a very unique propagation environment, right? It's at a higher altitude. And so it's able to see many G-node Bs simultaneously. And as a result, it can cause uplink interference to a whole bunch of cell sites simultaneously if its RF resources aren't appropriately managed. So I think there's a really interesting RIC use case around joint optimization of drone flight paths that achieve all of the other metrics jointly with radio resources, and being able to sort of manage your eigenspace effectively with, say, mid-band spectrum in order to ensure that the radio resources allocated to a drone from one cell site aren't interfering with, say, latency sensitive time slots that might be happening on another tower nearby. So I think those are some of the examples of use cases that uniquely benefit from O-RAN. And I'm sure there are others. You could also think about autonomous vehicles, although you don't have quite the same unique RF propagation environment. So again, I would encourage us to think both about the application layer that sits on top that can be uniquely enabled, in addition to maybe the deployment scenarios that could be done more efficiently with O-RAN.
That's fascinating. So when you're thinking about drones, are you thinking about them as clients or as base stations themselves?
So that's a great point, right? There's kind of two scenarios there. One is just your typical delivery drone that we imagine will be in our future one day, delivering our food and our packages. And in those scenarios, the drone is really just a UE that's connected to an urban 5G infrastructure. And there's all kinds of interesting problems to sort out with how you're going to do all the real-time machine-to-machine communication, all the edge cloud infrastructure, broader than just O-RAN. But you do also have sort of these, rather than a cell on wheels, you have a cell on wings, right? The airborne cows is a whole other interesting use case where you might be using millimeter wave backhaul for augmentation. And there the challenge is, if I have a drone that's acting as a G-node B that's in an advantaged position over a large region, then radio resource selection algorithms might have all my UEs simultaneously go connect to that drone just because it's got the strongest signal strength, which would then quickly overwhelm it. You'd have congestion issues. So again, I think the radio intelligent controller in O-RAN is a unique resource that you can use to do all of the RF resource planning in both scenarios.
Thanks, Charles. Laurie, do you have something to add in terms of use cases that you see are unique?
Sure, absolutely. I think as an operator, this is one of the most important topics and sometimes one of the most difficult ones for people to grab a hold of. So I thought it would be good to highlight a couple of specific examples. You know, we experience a need for a variety of radios for specific use cases. And today's day and age, we're often limited by what one or two suppliers have to offer. So that can slow down bringing new technology advancements to customers. I think an open architecture enables more players to fill the gaps to address deployment specific needs. So some examples include, for instance, the in-building space. You know, customers want 5G indoors, and we need to bring a variety of options to the space as the customer needs are varied. One solution doesn't necessarily fit all. So if you go into, you know, a customer's warehouse and you want to put a 5G radio there, that may not be what works in a hospital. So having more options and a variety of radio and baseband vendors from which to choose, it helps us customize our solutions for our customers and ultimately provide the correct solution with the best characteristics for that customer. Another example is when different form factors are needed to satisfy zoning or even physical space requirements. So again, what one or two vendors can provide may not suffice, and flexibility can be the key to gaining approvals to do the physical installations that we need to bring, you know, service to our customers. So I think also with new service offerings and agility within this space, it requires innovation within the RAN and ultimately reduce barriers to entry. When we achieve open front haul, X2 interoperability, and vRAN, which can lead to ORAN, we give ourselves a path to evaluate these new services quickly. And that also allows us to introduce new services at scale. So again, one size doesn't fit all, and the ability to mix and match solutions to our needs are really going to help to push technology advancements. And ultimately, having the ability to disaggregate software from locked hardware is a necessity to see these use cases materialize.
So another question that has been on my mind is we hear a lot of talk about latency. And actually, at this point, I'm rather confused. Does ORAN actually lower latency, or does it increase latency in terms of, because now you have so much more software and general purpose hardware in the stack rather than specialized hardware, which in general works to reduce latency. So what about applications that require low latency? Does anybody have a thought as to whether ORAN is the right solution, or is that a use case where ORAN would be useful?
Well, yeah, maybe I can try here. I think that in principle, at least from the front-end point of view, from the RAN side of things, ORAN should not, Open RAN should not increase the latency. Now, in fact, it could actually decrease it somehow, because part of the functionality that right now exists in the BBUs in 4G is moved into the radio. Now, of course, the splits have to be designed correctly so that you don't increase, again, you don't create some other bottleneck, and I think that this is being reviewed and all of that in the ORAN work groups, and certainly the 7.2 split, I think that is efficient in that respect. It should be efficient. Now, again, as I mentioned earlier in my discussion, we have to be careful. What is it that we're trying to split here? So that if we, again, I'm going to go back to the earlier points I was saying, that if you insist in doing what people have been developing for 4G blindly and say, I'm going to be very stubborn and just want to go with all these millions and zillions of digital streams and the digitize like crazy just because I want to be digital, blindly like that, then you may get in trouble. And in fact, people are getting in trouble right now. And in terms of the amount of hardware that you need to put in the radio to do this, all these extra, calculations and the circuits and so on. On the other hand, if you do what we do, which is get a little bit more wise about it, then you realize that you can do the same or even better. In fact, you can do better if you simplify things. And, I mean, we're all engineers, or most of us here, and we know that the solutions that usually work in the real world are the simple solutions, not the complicated solutions. Simplicity always wins. And so that's the way we have to think. We have to rethink about, just don't take what exists out there and let's just automatically try to put it in the ORAN. Okay, let's just rethink the system a little bit and be smart about it.
Okay, and that kind of ties into maybe a later discussion topic. What we can briefly touch on it here is, so as you said, if we are going to think about doing it intelligently, but it's also, it sort of brings together the ORAN specification, which is now happening in the ORAN Alliance, and you have the 3GPP organization, which is developing what was traditionally the radio access architecture. So where does this come in? Where does this kind of thought process find a home? In which standardization body? Does ORAN need to work much closer with 3GPP, or does 3GPP internalize the fact that their future Gs have to be built keeping in mind that we're looking at open interfaces? So thoughts on how the standardization process would work out, or where these, very important issues get resolved.
So I can take a stab at that. And I think what's interesting about what's happening with ORAN is, yes, it's a standardization effort, open standards, open specifications, but it's also an open source implementation, right? And so that combination, it's not just standards, it's not just open source, it's sort of a standards-based open source initiative, and I think that's fairly unique. I think the other part that's fairly unique is that there is a software ecosystem within that alliance, and I am not directly involved in ORAN, so this is sort of a little bit, and someone looking out from the outside looking at this process, it seems like a fairly well engineered software architecture. And so all of those things, so open source, open specifications, well thought out architecture that is also happens to be flexible and open, in my mind, puts us in a completely different space in terms of thinking about standardization, right? If you have a framework that is well engineered, well thought out, and so flexible that in fact you can add new things in that, then it really changes the way we think of standardization. And as you were saying earlier, Monisha, I mean, it might be that, you know, now we think of this framework as becoming the standard rather than the next G becoming the standard. So I think there's real potential here for allowing us to think completely differently about standardization and what that means.
Does anybody else want to jump in there? James, go ahead.
Yeah, I just wanted to say, in general, for those of you who've been involved with 3GPP, that standardization body has been wildly successful. If you think about what that group has to do every quarter, all the different RAN working groups and pulling together all the requirements. So I'm a big fan, given the way that some of the political biases have creeped into some of the other technical standardization bodies. I think 3GPP has actually done a really good job there. And then in terms of ORAN, you know, I think ORAN and 3GPP, at least at this particular point in time, they're actually complementary, in my opinion. You know, the release 15 and release 16 of 3GPP really opened the door for this ORAN ecosystem to be created. And I think that the 3GPP members actually embraced this sort of natural evolution. And to give you an example, using your latency example, I mean, you know, in release 16, you have mini slots and two-step ratch, which are techniques to lower the access time. And, you know, that those are more physical layer things. But, you know, if you're communicating with a device that's thousands of miles away, well, the round trip latency is going to be a function of physics. And in an ORAN network, if it were to implement these techniques like mini slot and two-step ratch, just as two examples off the top of the head, then if the service for that was at an edge device or a RIC, then you can see that was located in a close geographic proximity, then you can see that latency would get the benefit of 3GPP and also the benefit of this open RAN architecture. So I see them as two things. However, I'll do the I can't predict the future, but I do want to give props to 3GPP and what they've done. It's been a hard job, and I think they've done a good job.
Amit, you wanted to say something?
Yeah, I was going to agree with James as well. I think 3GPP has done a really good job so far. And if you look at it, 3GPP is not just defining the RAN, right? So 3GPP is defining what the handset is doing, what the core is doing, and what the RAN is doing. And the interface between the handsets and the RAN is an open interface. I mean, we are buying handsets from one vendor and RAN and code from other vendors for the last 30, for a very long time. So that's an open interface. It's working well. I think that so far the interface between the RAN and the core networks has also been open and has worked very well. I think across the world in many networks, carriers are using on a market by market basis, they'll have RAN from one vendor and code from another vendor. I've been part of startups and other, where we have built RAN products that introduced the carriers and connected over the S1 interface or the IU interfaces that were defined by 3GPP. So that has worked well too. To an extent, the challenge over time has been how to do interoperability testing. And a lot of that work has been done normally. Either it has been done by the large vendors, or in many cases, the carriers have helped in getting that interoperability done. So on some of the previous products that I worked on, we had the support of some of the large carrier customers that we were working with to get all the RAN to core interoperability done. So I think what is happening in Open RAN right now is we are looking at just the RAN. If you look at the network, you have the handsets, the core network, and the RAN. And now there is an effort to see, okay, if we actually are willing to break the RAN into, in a way, smaller sized problems, whether it is RUs, DUs, the RIC, the centralized unit, if we can kind of decompose it, maybe it becomes easier for there to be more innovation, because otherwise we are dependent on just a few companies who have these things integrated. And that is what is creating new interfaces, which are not very well defined in 3GPP, because that's not what 3GPP was traditionally trying to do. So that is the space, and I think 3GPP is still doing work in terms of like defining the F1 interface between, say, CUs and DUs and other RAN interfaces, but still that has not been traditionally the area that 3GPP has focused on. And that is a gap, in my opinion, that the ORAN Alliance is trying to address at this stage. In the past, there were other bodies like the Small Cell Forum, which defined the IUH interface, which was trying to do something similar, or the FAPI interface. So other attempts have been made in the past to try to see how we take the RAN, decomposing into smaller elements, allow more innovation to happen. And that's what you're seeing in ORAN Alliance. And I think we have to be kind of careful. I think a lot of times we are intermingling when we use this open RAN umbrella. We mix up things like ORAN Alliance, which is doing interfaces, other groups that are developing open source software, the Telecom Infrastructure Project, which is actually doing specific software implementations. So these are different things, but hopefully they all lead to more innovation and more progress in the RAN space. But I don't think this is an alternative to, say, the 3GPP standard setting process. Just my thoughts.
Ivan, you have your hand up. You're muted.
So I was gonna say that one sort of, I don't want to say a problem, but one issue is that the speed at which things are happening is quite different in terms of 3GPP and ORAN Alliance. In the sense that one is driven by software community, which tends to do things at much faster turnaround times, even to a point where people don't really think through all the interfaces, but come up with implementation that sort of works, which then creates a problem later on, of course, but that's a separate issue. Whereas 3GPP tends to be way more thorough in terms of making sure that whatever interfaces they come up with are well thought through and satisfy certain performance requirements. Having said that, it doesn't necessarily mean that this cannot be harmonized in some way. And maybe we just sort of let the ORAN community run in these cycles of updates, frequent updates and frequent changes, whereas sort of 3GPP waits for a little bit to sort of see the stabilization of the whole thing and then declares it a standard. And it's not clear that all the standards are really needed to be done on 3GPP level. Maybe it can be done something like that.
Right. So let's switch to a slightly different topic now. I want Mihai, did you have something to say?
Yeah, I just recall that actually my team that is following closely the ORAN activities and so on, they've often given the suggestion that, and this may be relevant to the government here, that if national labs were somehow to pick up on this issue of interoperability, and do some more studies and rigorous, independent sort of from all the interest of each vendor and so on and so forth, that may be an interesting idea. So I just wanted to share that concept with this panel. Again, it's more like what I hear from my guys as a suggestion anyway.
Yeah, and I think, the power test beds is one way of doing it, and there are others. I think in the previous panel, HP mentioned that they have a 5G Open Innovation Lab. So there are ways to do this. And actually that segues nicely into the next topic that I wanted to discuss in a little bit more depth was the use of AI and ML. So we heard a number of speakers among you as well as the previous panel as to how the Open RAN will enable the use of artificial intelligence to better control networks. But we also know at this stage that AI is also not a cure-all. It has its pitfalls, it has its biases. And so how do we as a community ensure that things like, we talked about the digital divide. How do we know that the AI doesn't configure a network so that people who are already underserved are even worse off than before, right? Because now you have so many more touch points within the network to actually decide who gets service and who doesn't. In the past, the FCC looked at people getting service based on the signal strength they were receiving. But now today, signal strength is not a good proxy for whether you're actually getting service. It's all of the intelligence that goes behind the network, which gives you the resource blocks you need or provisions the network. So what are your thoughts on how we can make sure that as AI rolls out in Open RAN, that the checks and balances are in place to prevent these kind of things from happening? Manu, you want to take it?
Sure. Thanks a lot. So yeah, I think with especially AI or any model is only as good as the data that is available to it. So clean data sets and essentially this is also, again, talking about adjacent technologies. This is not necessarily a telecom or an Open RAN issue. AI has its tentacles in pretty much everything we're doing. So these issues of clean data, unbiased, what topologies should be built constrained, I think this is much more beyond what we are looking at. But just to bring it back into the realm of Open RAN, specifically the idea of developing the data sets for training and inference. So now this comes back to offline learning and online learning. And I think the consensus, somewhat at least in the specifications, if I'm not mistaken, work group 4, they are looking at some level of offline training initially, sucking all the data from all these disparate disaggregated elements, and then essentially running it into the models they're building to see what comes out. An interesting analogy is, yes, your question of the bias that may be introduced, it actually may go the other way. So if you've seen a very simple science experiment of how do you think you build momentum on a swing set, and when a robot was trained to do that, it actually started to pump its legs on the way back, which is complete opposite of what the human in the loop would have done to essentially do a task. So to come back to the point, the objective is going to be defined by the operator, and I think thinking in ML AI terms, we have to meet that particular objective. And in the AI, in the Open RAN world, that's going to happen at the RIC. And again, the RIC has also been broken down, and this ties into your earlier comment around latency. They've disaggregated the RIC even in meeting some latency bounds. So sub 10 milliseconds, sub millisecond, 500 milliseconds and above. So non-real time, near real time, and real time sort of RIC would be something where we clearly see. But just to recap, summarize, data, clean data sets, and then essentially building models, and one day also thinking out into the future, we might even not need any manual algorithms, because the AI RAN would probably be optimizing the different touch points itself.
So if I can maybe quickly latch onto that, and I think the data sets, as Manu said, is really important. I think in terms of verification, I think making data sets available to the research community will be pretty important. And then just another maybe smaller comment. To the extent that machine learning and AI is sort of involved in everything that we do, there is a tendency to think, well, it's going to do these bad things. But I think Manu again said that very clearly at the beginning. It's not as if there's one AI program that's just going to run the network. At least, let me say, not in the foreseeable future. And so there are objectives that are being applied to these models. And these are typically much, much smaller things that might be, optimizing energy and performance at the same time. So things that are really hard, but it's not as if you're saying, hey, here's a network, go run it, right? And so I do think it gets broken down into smaller pieces where, at least for the moment, there are very clear objectives that are being applied to the models that are being trained.
So if I may pick up on the question of data, and we have Laurie from Verizon here. So even today, the carriers they own the data of whatever goes through their G-Node Bs and E-Node Bs, right? Now, when you're talking about disaggregated RAN, you have a lot more data, but presumably all that data will still be owned by the carrier running the network. So when you talk about now having data available to the academic community or researchers, how do the carriers look at making training data or test data available to the broader community to help make sense of what's going on in your open architecture?
Yeah, so I can take a stab at that, being the operator representative on the panel. We encourage data sharing on test beds and anything with the academic community. We're largely engaged in it. I think where we have to be careful is when we're sharing data on a live network. So, Verizon has been expressly against that. We're very protective of our customer data. We don't share that, but we're very engaged in test beds. And we encourage that because you learn when you're on a live network more so than, on any other types. But we've been able to do that in closed atmospheres so that it's not impactful to our customers, but that we can provide that level of data and the interaction between elements that's needed to provide those test beds.
Ivan, you had your hand up.
Yeah.
And then Ashutosh.
Yeah. So I guess there is additional issue here as well, which is if we are monitoring and we have all the at least power test beds have capabilities of really observing quite large swaths of spectrum, and therefore we can generate a lot of data, record it, and so then the issue becomes who and how can have access to that data, and whether we can sanitize that enough to make it generally available to the whole research community, or whether we have to, as a community, have some sort of repository of data where you have to be vetted first before you're given access to certain levels. And so that's a very interesting topic that we, as both academic and non-academic community, should address sooner or later. And again, the ultimate goal would be to come up with something like famous JPEG picture of the lady, right, the Lisa, whatever her name was, right, where we can then sort of at least use that as a baseline for evaluation of whatever we are trying to play with, whether it's Open RAN or not, right? This is a general issue.
Thanks. Ashutosh?
Yes, Manisha. So I wanted to say a few things. What Ivan and we also part of the IEEE Future Network Initiative, where we are studying the applicability of AI/ML for various use cases. again, security being my topic, we have also been looking how we can take advantage of AI ML to do predictive security, right? That means before even the attack happens, based on the data set that you have, based on the behavioral pattern, past traffic, how can you detect that attack is going to happen and proactively prevent the attack altogether? In fact, within the Future Network Initiative, we have a security expert group. We are developing some use cases around that and working with Ivan, who is the co-chair for testbed, try to see how we can do some proof of concept based on some AI algorithm. Maybe some of the NSF testbed, we can try that. So I just wanted to allude to that fact.
Thanks, Ashutosh. Charles?
Sure. So I wanted to, I guess, note that I'm not particularly concerned about some sort of bias in AI resource allocation really happening in a realistic environment. I think if you think about a 5G network, it's sort of already stratified into network slices that have different QoS requirements associated with them, right? So you might have some real-time latency-sensitive network slices for ultra-reliable low-latency communication. You might have some best-effort network slices for general broadband mobile consumption. But you really have sort of SLAs and QoS profiles defined for those network slices already. And then it's really up to the RIC, Radio Intelligent Controller, to figure out how to deploy resources in the RAN in order to meet those SLA requirements. And really that's an optimization process. So I would suspect that near term, a lot of the AI that's going to be applied is really just sort of sophisticated optimization algorithms that are really no different than the way the radio resource management functions work in today's eNode Bs, right? It's just now on a disaggregated Gnode B, you're able to do optimization across sites in a more efficient way. I think, yeah, down the road, we may get to the point where there's some black box deep learning that's being used to do resource allocation, potentially. But again, I think we will have built up to that over time, and we'll have a lot of sort of less sophisticated, more QoS-driven models that we'll be starting from and using to validate along the way. So again, my point is we're not just going to hand over the entire radio access network to deep learning tomorrow as part of ORAN deployment.
Well, I mean, so in one of the previous panels, there was this notion about these network interfaces becoming like APIs on your phone. And while that sounds like a great way to go, it also opens up, and this sort of segues into the next topic, which is security. So when we're talking about opening up these internals of the radio access network in as easy a way as an application programming interface that's visible to programmers outside, right? As security experts, what do you think of that? Do you think that that is enhancing the security of ORAN, or is in certain cases, could that opening up new threat models that we haven't really considered in the way we design a 5G network? I think Cheryl, you had some thoughts on security in ORAN. Maybe you could chime in there a bit.
Sure. So what I wanted to just take the opportunity to share is just some of our perspectives on security, kind of pulling from our communications and cloud background. And so when we look at 5G and offering it via cloud, right, beyond some of the foundational security measures that are already built into 5G, you know, we really look at the IT and cloud-based design as offering defenders those new opportunities to be able to shift the cybersecurity advantage away from malicious actors and to the defenders. And so, you know, taking a step back as a cloud provider, right, we can leverage the scale, we can concentrate all of our resources, our engineering and expertise on securing that cloud. And what we see then is services that are then running on that cloud environment, like 5G, you know, can then, they have the opportunity to leverage those securities. And so, you know, we look at 5G then inheriting the cloud scale, reliability, security, and allowing those capabilities to be rapidly deployed, scaled, segmented with the tailored security measures. And so, things like virtualization, the cloud native approaches, containers, network slicing, as we've discussed, encryption, identity management, access control, these are all things that can be brought to bear to secure and then to be and tailored to meet, whatever the application is, certainly. But to the conversation we just had about AI and ML, right? We see this as critical to the path forward in security, not just for the core, but also for securing the RAN. And so what we've been able to do is really have these AI-powered autonomous systems, right? So leveraging what we can see, all of the data that we have as to how things are running in our cloud, and then applying that to security, right? To autonomously prevent and detect and respond to the predicted sophisticated threats at machine speed. And also, take that burden away from the cybersecurity workforce, so the people who would, have before been going through the logs and whatnot, and giving that job to machines so that that workforce can actually be put towards those more strategic tasks. And so, as we're looking forward and this security landscape is changing and how we're accessing this, like really, kind of a web-based system, our view is that the cloud, it can be a little daunting, certainly, but we view the cloud as a real opportunity, and the technologies that we've been discussing to really provide some enhanced security for an open and interoperable and standards-based 5G deployment.
Go ahead, Ashutosh.
Yes, no, this is an important topic. In fact, when you look at the evolution of the generation of networks, right, the threat taxonomy or the threat model keeps on changing, as I was telling in my initial talk. So you really have to look at end-to-end, open up the interface, look at the potential points of attacks can happen, and then build a threat taxonomy and look at the additional security pillars. I think some of them were mentioned: orchestration, slicing, edge cloud. So these are benefits. You can take advantage of that. If you're having a jamming attack, you can probably do some kind of a dynamic radio resource scheduling. You can use SDN and NFV scale up, provide elasticity. You can really have security monitoring at different interfaces like data plane, control plane, to see where the potential source of attack, where it's coming from, right? So if you have all the security controls properly in place, you really should be able to take advantage of the ORAN features, but at the same time protect your assets from the attacks, either from the subscriber side or from the internet side. So security should not be an afterthought. As you design your network, as you map your application with a specific parts of the network, let's say for ultra low latency, you need edge cloud. If you really want to have edge security detection, you need to put them in the edge. So do that mapping and then find out what kind of security controls you have, what else you need. I mean, I'll just give you an example. You are working very closely with Department of Homeland Security right now, and they like to really take advantage of 5G enablers that we have today. We're taking a stepwise approach. We're actually working very closely with this power test bed. Many of them are present today as panelists. So we're looking at the requirement. We're looking at the KPIs with the latency. And Manisha, if you remember, we thought about key security indicator, like not KPI, key security indicator, KSI, right? So what are the potential risks? What is the probability of attack, the threat factor? Once you determine that, then you see the granularity of attacks, whether you want to put more security control at one network asset versus another network asset, right? So this really need a, I think Charles used to call it threat model. So we need a threat taxonomy and try to figure out the opportunities, the challenges, additional challenges, and then come up with potential mitigation technique, and then work with the testbed like Power and do a proof of concept, apply different use cases. And things do not work, go back to standards, go back to 3GPP, IEEE, ITF, ITU, and try to change. I know HCNFP started the security expert group, right? So this is how it has to be an iterative process, and it has to be all driven by application, use case requirement, and flow down.
So Charles or Cobus, any of you, can you point to any new security threats that you think might arise as a result of the disaggregation of the RAN?
So I think one, you know, if we think of one of the key primitives that 5G provides is the aspect of slicing, right? And so slicing is about isolation. And now we're saying, well, wait a second, we're going to have this thing that is going to have a cross slice view. And oh, by the way, we're exposing a bunch of interfaces here, and we're going to run applications on top of that, right? So I think for me, that's, and it might be a small one, but that's an example of, wait, this is something completely new, because we've had these isolated slices. Now we, because of the benefits, introduce an entity that has a view across those slices, and we're going to have applications running on top of that. And so I think I can generalize that to say, I think the largest unknown here is because it's a much more complex environment. We don't really know, and this is Ashutosh said the same thing, right? We have to work through those. We have to work through use cases. We have to figure out the threat model or threat taxonomy. But we have, I mean, we have an inherently complex system, which we're now opening up by a bunch of open interfaces. So at the very least, we have to acknowledge that we are opening, we're making our attack surface much larger than it used to be. And we have to think carefully about what that means and what new attacks that might enable.
And I would say that I think this gets to what the actual scale of the business models of 5G end up being, right? There's two very different scenarios here. There's one scenario where a 5G network basically is running 3 network slices, an enhanceable broadband slice, an ultra reliable low latency communication slice, and a massive machine type communication slice. Each one has a default sort of set of QoS requirements associated with it. And it's really kind of carrier centric in the way that they're operated and monetized. And then, okay, you've got 3 different apps that are plugging into your RIC that are expressing the QoS requirements around those 3 slices. That's all really contained within the carrier ecosystem. And so the carrier can be responsible for the security and robustness of all of that. It's not really open in the sense that just the iPhone app ecosystem is open. The other scenario says, well, every single enterprise network is going to have their own network slice. Every single different sort of industrial IoT vertical is going to have its own network slice. And our carriers are going to be running, I don't know, 200 network slices or 1,000 network slices, in which case this is a much, much more complex problem. It's not clear to me the sort of timeline of how we get from 3 network slices to hundreds of network slices, but I think there's will be plenty of time along the way to sort of see how all of this changes over time and really build up sort of incrementally the trust in how we would vet these apps that might be running on top of the RIC. I just don't see hundreds of them by 100 different third-party vendors all showing up initially, right? I think initially it's all going to be more carrier-centric.
But as somebody said, you know, we didn't know about Uber when 4G got standardized and implemented, and we don't know what's coming, waiting for us around the bend once 5G gets deployed. So changing topics now a little bit into testing, there was a comment in an earlier panel that testing and integration of Open RAN is not really that much different from the kind of integration that happens in networks today. We do that all the time. We are testing, we're putting together things from different vendors, and we have to do interoperability. My personal opinion is the Open RAN scales that problem up a lot more. So when we talk about testing, I know the ORAN Alliance has testing subgroups, but who at the end of the day, is it the carrier that is responsible for making sure that all of these interfaces are tested, work well? Is there a third party that aggregates the network together, who's responsible for making sure it all works? There is also a question about performance versus ORAN trade-offs. I've heard in other contexts that it is really hard to come to the same performance as our current networks as URAN, and I've heard the opposite too, that now ORAN can beat, and we've heard about how spectral efficiencies increase with ORAN. So how do you put all of these varying demands on the network in terms of testing together, and who does it, and where does it get done, and what are the research challenges towards doing it? Yvonne, you have your hand up, so why don't you go ahead?
Yeah, so I just want to draw on the previous or on the experiences that we are currently having, and you know, both as I said, both Powder and Cosmos are OTIC, meaning we are hosting these POCs where the people come in. So I think there are actually two issues here, right? One is sort of having the environment where players can play with the stuff or show that things are working, and then somewhat a different issue as to who can certify that things are what they are promising they are. And I'm not saying that one place cannot do both things, but certainly there are different objectives, and therefore probably it shouldn't be a single place, right, where these two things are happening. Then the second aspect of the whole problem is the fact that we are talking about really a fairly non-trivial number of different environments, where, especially including verticals and things that we are not necessarily used to, being viewed as a target for various components in this system. And so then this idea of having a single place where you're going to verify that everything is working according to plan is probably not feasible at all, unless you're talking about some very sophisticated environment where we can, meaning something that sort of extends beyond a single physical environment. And given that we are pushing performance really further and further away from what technology can actually deliver these days, chances are that that's not necessarily the ORAN type of thing. And that's something that you touched on, where people are saying, oh no, in this particular case, fixed function radios are way better in terms of performance than fully programmable software-based constructs, right? And so therefore, I mean, there are this whole range of things that we need to be testing, and arguably whole range of environments that it needs to be tested, and therefore whole range of test beds that need to be available for people to test things in. Completely independent issue becomes then who certifies that your VNF is really based on 3GPP specification A and ORAN specification B, or interface B, and it's working well with somebody else's core network or any other component. And actually the number of components and the number of combinations we can actually play with makes this a somewhat non-trivial integration problem.
Laurie, you want to go next?
Sure, I was just about to piggyback on what you said, Monisha. I think it's the whole ORAN community's responsibility, not just the carrier, the vendor, or the manufacturer. You know, testing challenges, they can be a threat when it comes to Open RAN. And from experience of testing on wide scales, sometimes it's difficult to identify the piece of hardware or software operating out of spec when there's so many different multiple vendors that are being represented and evaluated. That doesn't mean that it can't be accomplished. It just adds a different level of evaluation that needs to be done. And it's a layer of complexity that can be resolved by eliminating proprietary interfaces and standardizing with mature technology.
Thanks. James?
Yeah, I was just going to say, just make 2 points and piggybacking on what Yvonne said earlier. All of the components in the system have to perform to 3GP specifications, whether they're ORAN or not. And so that's a given. And that ensures a minimum level of QoS and compliance to FCC regulations and other standardization bodies. So ORAN doesn't alleviate that onus. And then just as a general point, Laurie's point earlier about the ORAN community having to self-police itself, and I think that the ORAN community does believe that we have to do that. And at some point, you know, these interfaces, it's just going to be accepted that they work, you know, and the testing will be light. But I don't think in this time frame, the early time frame, that it is going to be a little bit of, it is going to be a challenge to ensure interoperability. But but we all have a vision, I believe, of getting there.
Great. Manu.
Sure. So I think there is the time's not, you know, near, and not to put words in Laurie's mouth, but anywhere near a production operator environment, a test ORAN element is going to be assimilated. The way the big four data center hyperscale networking operations work is real-time debugging, fixing, feature addition happens in a live operational network. That paradigm is something that needs to be maybe rethought. I do still agree that there is some sort of a separate entity, either the ORAN Alliance itself through the OTIC program, or someone else that sort of does take the burden or shoulder the burden of doing a lot of the interrupt activities. And then we, I believe as a community, and most likely the operators have to drive this, have to think of what's the pathway from somebody who's working in academia, who then is entrepreneurial in nature, comes together to a startup, comes to a forum such as ORAN, validates what they have done, meets all the performance QoS and metrics and KPIs put forth by 3GPP and ORAN, and then what's the onboarding model? Right now, each operator has their own self-defined one, and it works well for what their metrics and objectives are. But I do think there is a place for an entity, a testing entity, either spread across, and maybe it can also be topical, but something where the operators have the front row seat into observing what's happening and mirroring what's happening in their own production networks to see what might make that jump or make that shift.
Amit, go ahead.
Yeah, Manish, I wanted to make 2 points here. I think first is that we talk a lot about interoperability, but I think it's more than that. It's about continuous integration because features do change. So we can get initial interoperability, but 6 months later, there is a new feature that a customer wants to introduce. And often that feature may affect the handset, the RAN, the core network, the billing system, OSS. And you basically have to figure out how it all gets integrated before it can be rolled out in the network. So I think that's a topic I don't have a solution to offer on this call, but I think as an industry, we have to think through how we are integrating and rolling out new capabilities on a regular basis. I do think doing that does require a lot of technical expertise, whether it's at whoever is doing the system integration, whether it's a third party or whether it's a carrier. You do require a fair amount of technical expertise to pull that off. And I think that's going to be a big challenge for smaller carriers. I think one of the comments that was made early on was that, just early on in today's forum, was that perhaps smaller carriers or rural carriers who have Chinese equipment should look at, using ORAN equipment. And I was thinking, I've worked with rural carriers in the past where the entire network department would be one person, and this person would mainly just have a CCIE certification that he can operate Cisco equipment, and that would be about it. He would be like an IT person. And now if we go to this person and say, we've got this, make this ORAN equipment, all this ORAN stuff work, it would actually not work out. So I almost feel that a lot of the open architectures that we're talking about actually lead to more consolidation in the industry. The example Manu gave about hyperscalers doing all this continuous integration. Actually, what we have seen is in the data center industry is that now you only have 4 big companies who can run, 4 or 5 large companies who can run data centers in that fashion. and everybody else is out. So either you use a cloud from one of these folks, or you are not really in the business anymore. So I think we just have to also think about, as we're moving in this direction, what is the implication for smaller carriers in the market? And of course, as a lot of people have mentioned, what does it mean for the big carriers themselves in terms of how they are transforming themselves to benefit from this technology direction? But I think those are things to just consider.
Thanks, Amit. Ashutosh, did you have something to add there?
Very quickly, I just wanted to make people aware that there are different kinds of testing, right? We have conformance testing, specification testing, then you have another thing where you have a specific use case or application, and you want to make sure the KPIs are properly met or not, right? If you're doing an ultra low latency application, you probably need the functionality of Edge Cloud, right? If you're just sending lots of bandwidth and file transfer, you may not need that. So I get that mapping is important when you try to do some testing. I know we have been doing a lot of stuff in the power testbed, some of the DHS fast responder use cases. At the same time, within IEEE, and Yvonne and I, we are developing some testing procedure as part of the Future Network Initiative roadmap technology. So I think there are different kinds of testing you're talking about here.
Right. And the question in my mind also is that, with all this disaggregation, we hope that networks do not become more difficult to maintain and upgrade, right? But I heard a couple of statements towards the thing that, when you add a new piece in, what does that do to the network? So what are your thoughts on, does this disaggregation actually make the network easier to maintain, or does it make it harder to maintain? Or is it somewhere in the middle? How do upgrades get rolled out? How do you test them once they get rolled out? Because face it, as soon as you move to a software world, you're talking about constantly living in a beta version, right? We're used to software that is always released without being fully tested. And so there has to be a way to think about how you do this network upgrade and maintenance in real time in an ongoing fashion. Who wants to take that?
I can give a shot at it.
Okay.
I think that one of the things, and Spirent isn't the only company looking at this, but if you look at the network, instead of doing end-to-end testing, there will be nodal testing on different aspects of the network. And then there are devices that you can hang off the network that also will be able to test any particular upgrades. So I think it's evolutions to existing test equipment that's out there. But as long as the test equipment has these interfaces, then they can test the individual elements that are being rolled out in a controlled fashion. And then the test and measurement solutions can scale to end-to-end and even down to the device itself. So that sort of mitigates the transition costs for these particular upgrades. So you can look at individual pieces, test individual pieces of the network, even if it's deployed, and then the solution scale as you roll out any particular additional service or feature.
Anyone else have any thoughts to add to that? Cheryl, I see your hand is up.
I was just going to add, from a software perspective, kind of going back to some of the comments I made about AI and ML, right? I think that there's a real opportunity that, as you're disaggregating and putting everything into software, once you're able to get your AI and ML, your autonomous systems up and running, the opportunity, just as we do in our cloud, is to, once a vulnerability is identified and the patch is ready, you can, number one, you can identify, when things are going wrong, but then autonomously patch in real time. And that's something that, we think is just absolutely critical whenever you're up against kind of the threats and the speed of the threats that are coming. And so, an opportunity as this matures and as we move to this disaggregation to port some of those techniques into this space.
So we have just a few minutes left, and what I'd like you guys to do is just I'll go in reverse alphabetical order and ask you each for one research challenge that keeps you up at night. What do you think this community should be looking at? And Cobus, you're up first.
So I just want to say I really like reverse alphabetical. For me, research challenges don't keep me up at night. Those are the things that actually make me sleep at night. But I think just to try to answer your question a little bit more meaningfully, I really think the whole idea of Open RAN and all aspects of it is really interesting from a research perspective. I do come back to the complexity of the system as a whole, the implications of that specifically with result to or in connection with security. And I'll go back to saying I think the way we need to get there is through experimental evaluation and use cases. So no, I'm not staying up at night. I'm very excited about it.
Great. Hope you get a really good night's sleep tonight after this forum. Yeah. Yvonne.
Yeah, so I was going to say complexity if I was first.
Okay.
That one,
you can repeat a previous.
No, I'm going to go to the next one down the list, right? Which is sort of what we can learn from the agile development community and continuous integration, and can we actually come up with some sort of a resilient deployment, continuous deployment, where we do partial deployment and avoid stuff like complete collapse of networks, which of course happens to all the big software vendors in this universe. So I don't know. Can we live for a few hours outage of a cellular system? I don't think so. But nevertheless, maybe we can learn something.
Thanks. James?
There's nothing that really, I can't point to one item or one thing that keeps me up at night, but I do think there is a need for a little bit of patience, because right now SA networks are just now starting to be deployed. And I think you'll see the benefits of network slicing as well as Open RAN. At least initially, some of these early deployments are really sort of, enhancing the enhanced mobile broadband case. But as we move forward in the short term, I think that once these networks are deployed with these interfaces, I think that it will create significant economic opportunity. I just don't think that we're there yet.
Right. Amit.
Well, I'm part of a new company, and we are completely focused on building this millimeter wave RAN product, and really focused on the economics, because I feel that radio access networks are access networks, and the most important thing is the economics, the cost per gigabyte in which we can deliver service. And if that works, the other things can, it will create a lot of opportunities. So that's what keeps me throughout the day and late at night.
Manu, I think one of the last things you mentioned, the cost per bit, has not been a research metric that the academic community has focused on much. No. But hopefully the NSF-powered and last rural broadband platform is one that will set that right. So Manu, I'll throw it to you.
Yeah, so just really quickly, I would say one is incentivizing and attracting the academic community. If you look at all these forums and alliances that are out there, I encourage you and urge you to look at the membership roster and try to identify a single US academic institution that's there. You'll be hard pressed to find one.
Yep.
So this is something I believe for the policymakers and federal agency sponsors, something to think about or to consider. The second is availability, and that might be tied to availability of software. The dearth of truly open source code that's available for an average graduate student, PhD postdoc to really absorb and understand the complexities. But even for a single deep dive in a singular element, some of that basic hardware and software infrastructure, which we in the Power ecosystem are really trying to put effort into building up a repository where really code is available unencumbered through some of the other IPR issues that we haven't discussed here, would be really important to bring to the fore. And then all of this ties into training and workforce. All these companies that are out there need to hire the students coming out of the academic institutions. And if they aren't ready, the pipeline is not being built as you're deploying Open RAN, and you're going to start thinking about that 2, 3, 5 years down the line. I just want to make sure that we emphasize that and we build this continuous pipeline. But again, absolutely, I didn't mean to sound ominous. We're very excited. This is a great time for Open RAN research.
Laurie.
So I'm lucky, like my peers, James and Cobus, that this is not what keeps me up at night. But you know, one of the things to keep in mind is that this isn't a one-size-fits-all network architecture. Mm-hmm. And I think that the research will help us, you know, bring us together from an implementation and from a standards perspective. So, you know, 5G is really interesting. It's different from 3G and 4G in that, you know, each company is focusing on what they consider to be strategically important. And that could be very different. And I think the more that we get research out there and testing and standards, it's going to help us to bring